At some point, almost everyone who works with data hits the same wall. You try to add two numbers together and get an error. Or you sort a column of dates and they come out in the wrong order. Or you import a spreadsheet into a database and half the values disappear. And somewhere in the error message, you see a phrase that explains nothing. Type mismatch. Most people Google the specific error, fix the specific problem, and move on. But the error is a symptom. The real question underneath it is more interesting. What is a data type, actually? The textbook answer is, a data type tells the computer what kind of value is stored. Integer, string, boolean, date. That answer is correct. It is also almost completely useless, because knowing the names of data types is like knowing the names of road signs without knowing the rules of the road. You can read them. You don't know why they're there. Here's the deeper answer. A data type is a promise. When you declare a column as an integer, you are making a promise to the database. You are saying, every value in this column will be a whole number. Nothing else. No text, no decimals, no blanks, a whole number. Every time. The database holds you to that promise every single time a row is inserted or updated. But the promise isn't just about what the value is. It's also about what operations make sense on it. You can add two integers. That's a meaningful operation. You can add two dates. What does January 14th plus March 3rd mean? Nothing. You can compare two integers and say which is larger. That makes sense. Can you say that Tuesday is larger than Thursday? In most contexts, no. You can split a string in half, but splitting an integer in half, what does 247 become? Undefined. A data type isn't just a label for what's stored. It's a set of rules for what's allowed to happen to that value. It defines the universe of meaningful operations and silently blocks everything outside it. That's the promise. And when the promise breaks, the error appears. Let's make this real. Imagine a spreadsheet tracking employee salaries. Someone enters £45,000 in the salary column with the pound sign and the comma. To a human reading it, that's clearly a number, £45,000. To a database expecting an integer, it's a string, a sequence of characters. The pound sign isn't a digit. The comma isn't a digit. The promise, every value will be a whole number, has been broken. So the database refuses it. Or worse, depending on the system, it silently stores 0. The data looks fine to the person who entered it. The computer sees something completely different. And that gap between what a human reads and what a computer stores is where type errors live. Here's another one. A developer builds a web form where users enter their phone number. He stores it as an integer because phone numbers are made of digits. Seems logical. First problem. A user in the Netherlands enters their number starting with 0. The database stores it as an integer and strips the leading 0. The number is now wrong. Second problem. A user enters a US number with a country code. +1 2 1 2 5 5 5 0 1 4 7. The plus sign and spaces break the integer constraint immediately. The form throws an error. Third problem. Someone tries to calculate the average phone number, which is a meaningless operation, but an integer column allows it. The type permitted an operation that had no business being performed. Phone numbers look like numbers. They are not numbers. You never add two phone numbers. You never find the average. You never say one is larger than another. They are identifiers that happen to use digits. The right type is a string, not because of what the values look like, but because of what operations make sense on them. That's the insight most people miss. Choosing a data type isn't about matching the appearance of a value. It's about matching the behavior you need from it. Think about dates. A date stored as a string, 2024-03-15, looks perfectly reasonable. But now try to ask, how many days between two dates? You can't. You're comparing text, not time. Try to sort a column of dates stored as strings. 2024-10-01 sorts before 2024-9-15 because the character 1 comes before 9 alphabetically. October appears before September. The sort is wrong. No error was thrown. The string didn't break any rules. It just couldn't keep any of the promises a date type makes. A date type knows that days come in months, months come in years, years can be compared, intervals can be calculated. A string knows none of that. It just knows the order of characters. Same data, stored differently, behaves completely differently. And this is why type errors often don't announce themselves. When you force the wrong type onto a value, the database doesn't always refuse. Sometimes it accepts it quietly and just silently loses part of what you meant. The leading zero disappears. The date sorts incorrectly. The calculation returns a nonsense result. The Saprovuzen type system didn't fail loudly. It succeeded at the wrong thing. So how do you choose the right type? Ask 3 questions before you define any column. First, what operations will I perform on this value? If you'll add it, subtract it, find averages, it's a number. If you'll search within it, split it, match patterns, it's a string. If you'll compare sequences, calculate gaps, sort chronologically, it's a date or time. The operation determines the type, not the appearance. Second, what values must this column reject? A good type is a gatekeeper. It should block values that don't belong. If a column should only ever hold whole numbers, make it an integer. Don't make it a string and hope nobody types a letter. The type does enforcement work for free if you choose it correctly. Third, what are the edge cases? Phone numbers, postcodes, ID numbers use digits but aren't numbers. Ages in months for infants are integers but the unit must be defined. Prices are decimal numbers but the number of decimal places matters. Currency matters too. The edge cases reveal whether your type choice will hold up under real data. Data types are not bureaucracy. They are not the database making your life harder. They are the foundation of every promise your data makes about itself. And every query, every calculation, every report you run is built on top of those promises. When the foundation is right, everything that runs on top of it works. When it isn't, the errors don't always arrive immediately. Sometimes they arrive months later. In a report that's slightly wrong, a sort that's subtly off, or a calculation that nobody can quite explain. The type was set once, long ago, by someone who matched the appearance and not the behavior, and that single quiet decision has been producing quiet wrong answers ever since.